Hello everyone, thank you for joining and welcome to Python and R for Data Science channel. I am your presenter Jason Kenyo, and today we are going to pick from where we left last time. Previously we had introduced R, why is it used for statistics, or how it came to be used for statistics, and basically we said that R was developed with data in mind. After introduction to R, we looked at R data objects, and here we introduced two types of data objects. They are all atomic data types and they are all derived data types. From atomic data types, we get derived data types. All this content is on YouTube, and the materials, that is the notebooks, they are on GitHub. Please check on YouTube for the GitHub link. Alternatively, if you want to, or if you are interested with GitHub materials, this is the link to GitHub repository. Should be tutorials. Yeah, that is the repository. But coming to the channel's repository could be easier instead, because I'm not sure that if that is the spelling of the repository or not. So go to github.com/pyr4ds. There you will find tutorials repository with all the code base for the channel. So as I was saying, we introduced R data types, the atomic types, and then derived types. With the derived types, as I earlier mentioned, they are data types that are created from atomic types. We went forward and explored a number of these derived types, looking into them all in detail, from vector, matrix, and all that, and we stopped at data.table, or rather data frame. And today I wanted to pick from data frame. Here we constructed one data frame, and I mentioned that there are a number of packages that are used to manipulate and work on data frames. And to be specific, the most commonly used, there is the data.table package, and there is now the dplyr package. So for today's session, we are going now to look at the data frame in more detail and look on how we can operate or manipulate data set in a data table using dplyr package. So today's session is all about data frame and dplyr package. So what is data manipulation? Data manipulation is a way of modifying a data set to make it more organized and more useful. In this case, you have got some raw data somewhere, which of course may make sense to you, but to some people, or even to you yourself, you may not be able to operate some mathematical or statistical operations with the data in the form it is. Take for example, you have obtained a data set from somewhere which has a numeric column represented as a character object. In that case, you will need to convert the character object to numeric object so that now you can be able to carry out statistical operations such as doing summations, getting means, getting median, getting minimum value, getting maximum value, and all that. What I will cover in this course, I will cover the five verbs, or the five main verbs that are introduced into dplyr package, but there is a lot more that you can do with it, with the dplyr, that is including now grouping your your data set are using a certain categorical value when doing now some other operations like getting the mean of that group, getting median of that group, getting sum of that group, and all that. There is a lot more that I will not cover for today. So for today, the focus will be on the 5 main verbs, and that includes mutate. Mutate is a function that is used to add new variables that are functions of existing variables. Then there is the select verb, which is used now to pick variables from the data set based on their names. That is, you pick certain columns and leave the others. Then the filter, it picks cases based on their values. Now this is the same filter as this is subset as if we were in base R. So here we are picking cases based on a certain logical test. If this row matches a certain test, give me that row. If it doesn't, just leave it. Then there is summarise. This one is for taking summaries from your data set. And then finally there is arrange. Arrange is used now to sort or order your rows based on a certain criteria. And all these ones, they are combined with the group by, which allows you now to perform any other operation by group. By group I mean you group a certain data set by a certain category, then there you can get the most occurring value in that group, the minimum value for that group, the mean for that group, the maximum value for that group, standard deviation, and all the statistical bit that you can compute for a group. You can do it after now using the group by verb. This one I not covered it, but I will tell you how you can go about using it. It is very easy and very powerful. So let's get started by now looking at the data set. 2 requirements for this course. 1, dplyr package has to be installed on your machine, and secondly, the data set. The data set is included in the repository, the data folder. So let us take a look at our data set. This data set, I extracted it from world meters a repository. This is the population by country metrics. So what I did is I copied the table and pasted it into a CSV. So my CSV is not typically a good CSV because it contains spaces. See, 1 space China space the value. I don't know what that value is, another. But the good thing about this one is that now I mapped now the column names here. I have the column names. Then I have the data set. I know the separator here is not the comma separation, not but a space. So what we do here with that information is you declare the column names first, then load your data set. How you load your data set? Use base R package ready.csv method, then input the path to your data file. Here our data set has no header. It has no header. So we are starting the first value, and this should be the first line should start here. Yeah. Okay. Yeah, should be there. So it has no header, so header is false. Separator, it is a tab. See? A tab. Yeah. And that is it. When you hit run that one, this is how our data set will look. When you run now this chunk, sorry, yeah. So the first row has China, V3, V1, V2. So these are the column names which are auto-assigned by R. But no, we are not interested by those auto-assigned column names because we already know the column names for our data set. So to assign the column names, you do call names of our data, you give it or you assign it to our declared column names vector. Execute the chunk once more, and now that is it. This is a data set now. Looking at this data set, it is interesting, and we want now to make this data set useful and more organized. For instance, take a look at the country column. This column represents character data type, and of course it is represented as character. So there is nothing much we can do about it. But go slightly ahead and look at the population column. It is given as character type, and whoever did the typing, okay, it has the numerical separation commas. So we need this column in numeric form, and to do that we need these commas. We need to get rid of this human readability separator commas. So that said, let me show you other columns. Density column, it is character, so it has to be converted to numeric. Same case for land area, migrant, fertility rate, the issue could be a percentage or something, mid age, that is urban population in percentage, and body share. Funny thing is that at times working with these percentages may not work. Assume we want now to take a portion of countries and compute the world share taken by that section of the countries. You will find that you will need to convert, or you might have to convert now these percentages to numeric, then sum them up, and then give your result as a percentage. So you have to manipulate the column as well to make it more useful. So let us get started by looking at how each of these dplyr verbs are used to manipulate the data set. And the data set that we shall be manipulating is this our data frame here. So let's get started. First thing, we look at we can start by okay, let us form a question for ourselves and try to answer it using now the verbs. This is a data set, and we need it first arranged in order, ascending alphabetically by the country name. So we can start here to do that and engage the, here you engage now the, this is the fifth verb, arrange. Let us start with arrange. Okay, verb are first we load our package dplyr. If the package is not installed, please install. How you do that? Install .packages dplyr. Yeah, that is it. Install that one. So say data. Here I'll use the pipe operator. There are two ways that you can operate on your dataset using dplyr. Let me demonstrate it here briefly. You could you could, okay, let me have it as part of arrange verb. You could start with arrange function, which will take now the data set as the first argument, and then you can continue now to what you want to do with arrange. I want to arrange my data set by country. The column is country or dependency. Be sure you don't misspell anything. Close that. Yeah, arrange. Let us see. Oh, we had not loaded our package dplyr, so now that this are loaded, you arrange already. See, our data set now is arranged in alphabetical order by the country. Go to the next. See, it is well arranged now. But okay, this is one way that you can work with dplyr verbs. Secondly, you can use the pipe operator. What the pipe operator does is that it gives the value on the left is provided as the first argument for the function that you are about to call on the right. So doing the same thing that we have done above using the pipe operator is that now we don't explicitly provide the data. So here what happened is that assume you are doing a series of manipulations. You have selected and filtered, you have done mutate, and then you want to finally arrange. I will show you that. It will be very easy using now the pipe operator. That is now the output of one step forms the input of the next step, then output of that step forms input for the next step, and so on and so forth. So here already by using the pipe operator, we have data object given as the first argument for our arrange verb. So what to provide next is not the data, but now the column you want to, the column that now you are arranging or sorting your data by. So country, this is all dependency. Yeah, see, cool. Yeah, must be cool working with it this way. Same result. Our data is not arranged. See, we are not assigning the arranged value to our data. So if you are looking at the data itself, let me do it in a temporary chunk here. Data, our data is not arranged because we are not assigning the arranged value to the data. So here the first one left the data intact as it is here originally. We have not modified the data. So what you are seeing here is the result of arrange without assigning out the data. Same case here, not assigned to data. That is very important also to note. So that is how you use the arrange verb. Assume you want now to arrange not in ascending order but descending order from Z to A. What you do? Add descending here. So let me do it in a separate chunk. Sort descending data pipe operator, then arrange descending by country, all dependency. Yeah. Execute. There it is. It is arranged in descending order now. This is ascending order from A to Z. This is descending order from Z to A. Next question. We have our data set arranged. But now looking at the first column, actual index column, this column doesn't make sense because okay, 74 here, Zimbabwe 74, Zambia 65. We expected that the index column goes with the whatever arrangement or sort order that we are using. So if we went for descending order, Zimbabwe should have come index 1 going onward. Same case here with ascending order, Afghanistan should have taken index 1, Albania index 2, and so on and so forth. So this index column here is misleading and doesn't carry any weight. Having it or removing it, it is the same thing. After all, we are going for the auto assigned order or index based on the order criteria that we are using. So let us go ahead and get rid of that column. So the next thing is work without the index column. Arrange in that order, work without the index column. So delete index column. So here we go for data. Now here note, we are going to do a series of pipe operations. First we are starting with the data. We remove the index column. How you remove is provide negative, then the name of the column. We have removed the column, pipe operator. Now arrange your data set using country, all, dependency. See how useful pipe operator is. Data, field it into select verb, then output of select verb, field it into arrange verb. Execute that. We misspelled something. Yeah, this name dependency, yeah, sorry for that. So now here we don't have this other column. Yeah, we don't have the index column, so it is not giving us it is not confusing us. You see by looking at this data set here, one may wonder what is represented by these indices when it is just nothing. But here now we are clear, it's no longer there. So let us form another cool question here. Assume our analysis is interested in looking at the population itself, net change, and maybe population density, and urban population and world share. Just those. We are not interested in the rest of data variables in the data frame. You are interested with the urban population, world share, density, population density, net change, and population. That is in the year 2020. Or you do that. So we have to get rid of all these others. So first, let me use this one. So here we already got into select verb. I should have noted that hash. Don't worry, I will compose this markdown in and document it very well. So by visiting the channel's GitHub repository, you will have better markdown with better documentation. Don't worry about this. So we are doing this one for the tutorial, but one that will be uploaded to GitHub will have more details about the verbs themselves, what they do. So the next thing, I'm carrying the same thing here. Here we want to okay, working data. Here we are okay, remove the actually we even should not even be removing. We can just get the columns that we need, and these columns are we need to work with, or we are going to work with first the country, all, dependency, That is the first column. The second column that we are going to work with is the population 2020. So this is subsetting or just extracting the columns that we are interested in and leaving the rest. Net change. Population density. And finally, urban population and world share. And world share. Yeah, these are the columns that we are interested in. The rest we don't care. So we can even assign this result to area of interest data. Go to that. Head of area of interest data. Execute the chunk. See? Okay. I have outputted just the head. Let me show you the whole data set how it looks. Okay. The head shows you now the correct index 1. The first item will get index 1, Albania 2. Yeah, the right index that we wanted using the arrange. Now let me show you the data itself. This is the data set of our area of interest, just 5 columns. Country or dependency. Let me maximize my video to see if I can have everything in the same screen here. I have it all in the same screen. So I have the country, population, net change, density, population density, urban population, and world share. Just those six columns, nothing else. See? With this other one we add see, we have all this junk. This forward backward icon here means there are some hidden columns, but here we don't have any hidden column. We just got a subset of the columns that we are interested in, and now we can proceed now to doing other manipulations into our data set. So the next thing, we can look at the next question. We have now a good subset for our data set. How? Yes, we need to convert now some of these columns to appropriate data types, so that now we can be able to do statistical operations. So the next verb should be mutate. Yeah, but before mutation, okay, yeah, okay, let us go for the next verb to be mutation, where now we convert mutate verb. Here now we are going to convert a few of these columns to appropriate data types. So cast data types. Okay. So the first thing is we are working with AOI, area of interest data. Pipe operator. The first thing is our area of interest in data is this ordered data, so we don't need arrange anymore, and we don't need to do any other select, because we already have the portion of the data set that we are interested in. So we can go directly to mutate. we want to change the column type. First let us try with this, the population. So let us say new population equal to looking at this column, we have first it is a character type, so we have to convert it as to numeric. So as dot numeric. The next thing, we need to replace the commas. This is human readability formatting. We need to remove that formatting by now removing the commas. So how we remove the comma? Use now the base R method gsub. We are substituting everywhere we have a comma, replace it with nothing. And what are we replacing? Now it is the column name. You put the column name there. So here is the pattern of replacement. As you can see the guide here, the pattern, replacement, and the variable that you are replacing. Execute this chunk to see what happens. Oh yeah, we have introduced a new column, and it has been assigned a type double, all numeric. That is what we wanted. Now we don't want to introduce more. We don't want to introduce more columns. Let us replace now the existing column with the computed column. So let us execute by renaming now the column name to the same name as the existing column name. Execute the chunk. Good. There we go. Population 2020. We have already converted the type to double. Let us do the same thing for all other columns. I think I'll do it in a new chunk. No problem. Or alternatively, I could even do it here. Yeah, no problem. Let us do it here. Sorry. So the next column that we need to convert is this one, the net change, to double as well. So net change has the same formatting as population. So just to change the column names, don't change the operation that is being done. Then here we need a comma. Then go to the next line. Then the next one is population density. I think population density doesn't have okay, it has the same formatting as these other two columns, so just leave everything intact apart from the name, the column name. So change the column name only. Then urban population has a percentage somewhere. This one doesn't go beyond 100, so it has not the formatting comma. So here with the urban population, what we are doing is we are substituting the percentage, not the comma, the percentage sign here, and then now convert whatever remains to numeric. Same case for word share. Replace the percentage sign with nothing. Replace the percentage sign with nothing, then convert the result to numeric. Good. Great. Execute the chunk. There we go. We have error message here. Oh yeah. This column add here we had a null value, so we are it's a warning that this column has produced nonce by coercion. It's okay for now, but of course now if you are doing real analysis, this one should have been a point of alarm. You should check your data set and know why is this happening. But because yeah, it is happening because of this value. But now you would go behold, having this? Why did we have this one? Then you could maybe have resorted to removing this row. Anyway, why don't we remove the row anyway? Yeah, filter. We should have done filter. Okay, let us do that. We don't need to yeah, okay, no need. That is a lot of work for now. We will take a look at the filter verb next, but we will not look into it in the context of now cleaning the NAS. Of course, there is another way, not null or remove NAS, but for now we give it a blind eye because our interest is in learning the verbs, not doing the actual analysis into the dataset or cleaning the dataset. So that is it. We have already converted the data types, and now we have appropriate object types that we can now do some statistical analysis into. See, this is another that we are talking about. It is weird having it there, but it's very okay, no problem. We can keep it there. So we have converted the data type to suitable types that we can now use for statistical analysis. Good. So we have two more verbs left. The next one, let us take a look at filter verb. Yeah, filter verb. Filter verb. With the filter verb, what it does is you can use it now to pick values based on a certain, to pick rows based on a certain logical test. Here, with the select verb, we are picking columns. We are picking columns or dataset based on column names. With the filter, we pick rows based on a certain logical test. So assume our logical test is that we want to pick we want to analyze world share by percentage, and this value is too big. Yeah, this value is too big. What okay, we didn't change this. How? Yeah, so we should have changed here. The world share value is too big, should not be that way. Oh yeah, this is very okay, very okay. So assume we want to take a look at the world share for 20 countries at random. So let us pick world share 20 countries. Okay, let me use the hyphens. Okay, so we need to pick 20 countries at random. So we can pick okay, this our area of interest data is already arranged. So to pick it at random, we can use our data, which is not ordered here. We can pick 20 countries from this raw data that we started with. To do that, we can do countries. Yeah, countries equal to data of country or dependency. We want to pick between. We can pick between 25 to 40. So that should be 39 because it is inclusive on one end. So to 39, those are 20 countries. Or we can even go to 49. Those are 30 countries. Yeah, makes sense. Yep. Or we could even do 15. We pick, those are about 40 countries. No, that is too big. Let us go with 39. 30 countries. That is 30. No. 2 that 5, that is 30. So if we go to 45, that is 40. Okay, we can leave it as 2 that 5. 15 to that 5, that is that 1. So 16. Probably 15 to that 4. Okay, let us pick that. So countries, let us take a look at what we have for countries. Execute the chunk. Yeah, these are the countries we have, 20 of them. 19, index 19 is Algeria. So Sudan is index 20. Yep. R labels from index 1 to 20. Very okay. So yeah, R does not have index 0. So we want to compute world share in percentage for these 20 countries, and maybe compare with the world share for China. Yeah, China, and see if these 20 countries occupy as much as the population in China. Okay, to do that, we first start with this our converted. Okay, this data that we did some sort of this data that we converted data types. We did not assign it into anything. So our data, area of interest in data, it is still raw. So what we need to do, we can just copy this chunk here instead of coming to assign and continue using the pipe operator. So the first thing would be to change data type. Then the next thing, honestly, to be resource intensive, you would first filter, because filter will consume less of CPU and RAM if you are working on a big or very big data set. So first you filter the data set, then do the type conversion to that subset that you are going to work with. Let me show you practically. So filter, we filter where countries, or so our filter criteria is country, all dependency is in. This is the logical test that we are doing, is in the countries, the 20 countries that we did subset from the raw data. Then the output of this filter, we feed it now to type conversion. Let us see what we have so far. Yeah, this is it, 20 rows. There's the filters worked. These are the country that we okay, yeah, this is it. Let me execute the whole chunk to show you what we have. These are the countries: Vietnam, DRC, Congo, Turkey, Iran, Germany, Thailand, United Kingdom, France, Italy, Tanzania, South Africa, Myanmar, Kenya, South Korea, Colombia, Spain, Uganda, Argentina, Algeria, and Sudan. Looking at our data frame, we have Algeria, Argentina, Colombia, DRC. So it is not in order. Is it in order? Germany, France. Yeah, it is in order. Yeah, it picked the order or arrange criteria from now the base. You remember first you started by ordering and all that. So by filtering, it didn't disarrange our data set. That is so cool. So we have these are the 20 select countries, and we say the purpose for this analysis is we want to pick, or we want to compute world share, total percentage world share by these 20 countries. So to do that, to do the total now, that is the last verb, which is R. Sorry. So this is the last verb now. dplyr verb, summarize. Summarize verb. Yeah. Okay. Sorry. So here you want to compute the sum or the share by the 20 select countries. So to do that, we have not assigned anything to this data set. So let us work with this chunk here. So first you use your area of interest data filter, where we have actually, let us assign it to something else here. Let us do that equal to, so that I don't confuse you. So that I don't confuse you. So our area of interest is composed of 20 rows, which describes now the 20 select countries. You could also even do a line graph for this. Actually, we can try not a line graph but a bar chart. We will do that. Yeah, we will do that to finalize the whole thing for the 20 countries and see which country had a higher population than the other, and how was the variation between these 20 countries that we selected by random. Okay, for this one here, sorry I took you far. Here we want to compute the total world share by these 20 countries. So to do that, take our area of interest data. We engage the last verb, which is now summarize. Summarize. What we want is okay, the first argument into this is data, which is already fed by the pipe operator. So the next thing it is to input the operation that you want. So that is world share. That is the name of the result that you are computing, equal to sum of world share. Okay, so that I don't confuse you, here we can use it total world share. Okay, the total world share to be assigned the sum of the world share by these 20 countries. Let us see the output for this: 16.14%. So these 20 countries account for 16.14%. Let us see what China accounts for. World share China. So it is the data which is not modified. We filter. The criteria is country, all, dependency, dependent, equal to China. Execute the chunk. Here we go. China accounts for 18.47%. That is higher than this one by over. That is more than 2%. Crazy. Yeah, crazy. But we all know China is overpopulated. So the last thing is okay, this is a bonus, not part of dplyr, and this is something that we will cover maybe in some future, not maybe, this is what we will be covering now in the next coming tutorials. If we are not going to look into data.table package, this is how you use dplyr to manipulate your data set and make it more useful. And after that, you could use now another package for visualization. It is called ggplot2. So you load the package. So this is what we'll be doing in future. There is also another good package called Plotly. It's also very good. I like it for the interactivity. You draw a graph or you read a graph, and then you can interact with data variables in the same graphic. We will also cover that one sometime in future. That is it for today, guys. Thank you very much. I appreciate your time and the attention you've given. See you in the next session, where we'll be looking at data visualization and see how we can now transform our figures, the figures that we have been working with today. We convert them or transform them into visual graphics that someone can interact with and extract meaningful information. For this session, all I can say is that practice and practice more. Load some data from elsewhere, not necessarily the data that I have provided for this course, but you can also check some other data. A classical example is the COVID-19 dataset, or some data from World Bank with more interesting data columns, or which is even not clean as this one. Try to manipulate the data and make it more orderly and more useful. For more information about dplyr package, please visit dplyr.tidyverse.org website for the actual or package reference. For today, I thank you very much. Bye. Thank you.